Good morning, everyone. I extend a warm welcome for this webinar of CSI for this academic year. I would like to thank the Executive Director of Don Bosco Institute of Technology, Reverend Father Mario Vaz, our Principal, Dr. Prasanna Nambiar, the HOD of IT Department, Professor Janvi Baikarekar, and the SBC of CSI, Professor Uday Nayak. Today, for this webinar, we have with us Mr. Anuj Garg. Mr. Anuj Garg is the founder of Code of Course, an initiative to provide mentorship and guidance to students. They are a group of people who are enthusiastic about open source contributions. He is Google Summer of Code admin for ReadArt. They have mentored over 10,000 people and conducted bunch of workshops. Also a mentor and organization admin for the past few years at JBoss Community, the open source outreach advocate as well. Mr. Anuj, I hand over the webinar to you, sir. So you may begin with the webinar.
Yeah, okay. So the problem was that my screen is not still in spotlight and okay. Okay, so you're talking about Uday or me? Uday sir or me? My audio was hiccuped for a second. Okay, so I'm in front. Okay. Hello guys. So I was having a bit of network disturbance, but I'm back. And I hope everyone can see me now and we can start the discussion. So hello guys. And today we'll be discussing a lot about machine learning and artificial intelligence. And I hope every one of you is, having a basic idea about what exactly is machine learning, what exactly is AI, and what exactly we can really generate with all these kind of things. Okay, so I will share my screen so that we can discuss things more appropriately and we can go in depth of a lot of content. Okay, so I hope now everyone can see my screen, and if there is a problem with anything, you guys can put that up and we will take care of that. Okay, so what exactly is AI and what exactly is machine learning? And let me know if I'm clear on this.
I think we have some technical issues. We'll be right back. Just give us a few minutes. Okay.
Was an interruption in internet. So can anybody see me now? The process is completed.
Yes,
Yeah,
sir. Yes, sir.
cool.
You're audible.
Yeah, cool. Okay, we are back. Yeah, so yeah, so we were talking about. Let me just put it on the refresh as well so that I can see where I'm now. Yeah, cool. My screen share. backup, and done. Good. So we were talking about what exactly is AI and what exactly is ML. And Arjun has said the process of using computer to generate knowledge from data. Yeah. So that is ML. When we talk about data, that exactly is ML, not AI. AI is more generic. What is AI? People say that, just as a full form, AI is artificial intelligence. And, you may say, some of you may say that artificial intelligence means that if something thinks like human, but it's not like that. Okay, because human have a very basic and specific thing. इंसान के बारे में क्या फेमस है ज्यादा? Is it bias or removing the bias? When we learn something as human, do we target on the bias or do we target on removing the bias? What do you guys say? you know if we think of something, if we think that this thing is good or this thing is bad, does it does it create a bias or does it remove the bias? By default, the human knowledge is generated from the bias itself, but the computer knowledge that we want to create with data or with any specification, that is to remove the bias so that the decision it take doesn't directly get reflected by a particular bias. Okay, so thinking like human is not exactly AI. Okay, thinking like the general knowledge kind of perspective is not directly the AI approach of things, because eventually we want to remove the bias part from the structure. Okay, so human thinking and artificial intelligence will never align itself. Okay, artificial intelligence is more toward getting the prediction, but prediction can be from anything. Prediction do not have to come from the initial training with the data. Like, for example, you probably would have heard about reinforcement learning. Okay, like when you teach a dog to sit down and stand up, so you do not exactly provide the data. Okay, what exactly is standing up? You don't like sit a dog and you stand up, saying like do this and do that and you roll over and do that. Okay, you don't do that. You simply provide an instruction, and if the dog behave appropriately or nearly appropriately, you provide a feedback loop. You say that it is a right thing to do or it is not a right thing to do, and that's it. That is whole ecosystem that you're providing. You're simply saying that there is the environment and there is this agent is deciding the decision. So when you put up a additional feature on this environment, you say that in the additional state I'm providing this input, and now you have to this agent have to provide an action to it, and according to that action the state will change, and now there will be a feedback loop. I will provide what is the reward to the system. If you do that, what is my reward? And this loop is creating I will say learning pattern where agent knows that if this is the reward I wanted or not, and I will have to change my future actions according to that. So this is a reward system, and this is what reinforcement learning. So machine learning, reinforcement learning, these are all part of AI. Artificial intelligence consists of a lot of type of learning, and one of those type of learning is machine learning. Okay, so what we can say that artificial intelligence is a bigger topic in which there is a smaller subsection named machine learning. And machine learning says what? Machine learning says a very basic concept, that is, we have a model and we have this corpus. Okay, we have this model and we have this corpus. And what exactly is corpus? Corpus is just data. Corpus is data which we can provide to model, and then model can provide a response. So model is just a predictive algorithm where we are putting up the data and we are saying that respond to that. Okay, so now we are considering both type of learning, supervised and unsupervised learning. Supervised learning is where we have y, where we have the output for particular inputs, and unsupervised we do not have y. But in both the cases, you provide the input and corresponding to that it have to behave, it have to provide some y, even though you have same similar kind of y in your corpus or not. Okay, so when such kind of thing is happening, how do you manage that? Okay, there is this model, there is this corpus is providing data to machine, sorry, to model, and now model can calculate and compare this data back to the corpus, and corresponding to that you can check if the value you got and the value which was already there are different or same, and corresponding to that you can change the values of your model. And that is the way you are, training your model. And this is the structure of supervised learning. In the supervised learning, you're updating the value of your models, and because of that, the what I should say, the future predictions will be better than the previous predictions. Are you guys comfortable with this thing? You guys are able to understand what I'm telling at this point? That you're simply updating what should happen in your model, when you're predicting things, with the help of the previous predictions and the corpus, the data that you already have. Like if these are the value, if we have something like we have, generally there is this common data about cancer prediction, that is, the size of the cancer and the age. Okay, so like there are some dots. This is the location of age, and there is this one of size of the cancer, and we have a few dots here. uh, we have a few dots here. Okay, and if we put up a single point and we say that, okay, this is the point, this is the point, this is the point, this is the point, this is the point. Okay, so if we get a single point because of these values, the age and the size of the cancer, because of which we can put that up in the algorithm, and we can tell if this cancer is, hazardous or not. If this particular item that we have, that will be, that will create a difficulty or not. Okay, so Ashmita is asking, what do you mean by corpus? Corpus is simply data. you know when we say that your model will learn from data, obviously you will need both input and output. Okay, so like when we are saying that, if we know that these points are problematic parts, and these points are not problematic part, so when you put up a point, you say that if there is this this size and this age, corresponding to which the thing that we have is dangerous. If we have this age and this size of the cancer, this is not dangerous, or whatever. You have one cluster here, you have one cluster here, and you are providing this data. And initially what will happen, you do not tell what is dangerous and what is not. You simply put up the points and you keep on telling this is dangerous and this is not. So eventually it will have the capacity to know, if you provide any additional point, to which dimension it falls in. And at this point the data is very simple, but generally it keep on increasing the complexity, because there could be one more data, like where there was decision surface is more like this. Okay, where there are points of a class and class like this, and a class and the same class like this. Okay, so these point and these point belong to the same class, and these point belong to the same class. Initially you can think of like there can be a simple line which can provide the decision surface for this, and we do not have to really go for the hardship of a proper machine learning algorithm in this case. But what do you think about this? It will be difficult to directly solve this kind of problem with your normal mathematical solutions. Okay, and there can be much more complicated decision surface, for which you will have to eventually go for machine learning algorithms, where you do not want to put that much of effort in finally understanding what a decision surface will be. Decision surface is simply telling how to exactly decide to which category you want to provide your value in. Okay, it is like separating the classes. Whatever is outside this will be this class, what is inside this is this class. So the decision surface can be can get more complicated because of two reasons. Okay, one is if number of classes, number of classification increase, in that case your decision surface will be complicated. And if number of dimensionality increases, right now we are simply thinking about two dimensions, but if we say that there are 100 or 200 dimensions, what you do in that case, that will be much more complicated, right? If you understand this part, I really want to take you guys toward the ride of the programming part of things. And I hope you guys are comfortable with basic Python knowledge, because we will be using that a lot today. And if you guys do not have this Jupyter notebook installed, what you guys can simply do is let me just showcase to you guys that you guys can use this. Just 1 second. Google Colab. Google Colab, and you can create a new notebook. Just 1 second. New notebook. That's it. It will create a notebook for you. You can connect and you can start coding here. So the things that I will be doing on my notebook, you can do the same things here. You simply have to write down the snippets, and with the help of shift plus enter, you can run them. Okay, so right now, because I pressed connect here, we are getting connected, and now you can, let me just zoom in. Okay, so a is equal to 6, shift enter. It will just run this Python code on your, a remote Google Colab notebook, and you can simply get the value back. Okay, so it is as simple as that. I provided this very simple example because you simply have to understand what exactly, Google Colab does for you. And I will be doing the similar kind of thing with my Jupyter notebook. And let me open that for me. Yep. So let me create a separate directory for you guys. Workshop, and good to go. Cool. So we'll be coding here so that you guys can have much better understanding of the things that we are doing, because without code, what exactly is machine learning? We do not simply want to get jumbled up with the basic concepts only. We really want to create things. That is the thing that makes sense, right? Okay. So there's this question: can we use PyCharm? Yes, you can use PyCharm, but if you do not have this installed, I will suggest to use Google Colab today, because we'll be using some of the libraries, and if you do not have them installed, you will need to install them parallelly. But if you use Google Colab, all the libraries that I will be using today, those are pre-installed on Google Colab. Okay, because Google Colab is more like the Python environment for machine learning that Google is providing for free. And especially, they also provide what? They also provide GPUs. So, when you grow in the dimension of machine learning, you will eventually need, in case of image processing, you will be needing GPUs, that is graphical processing units, because, what exactly happens in the graphics, that there are a lot of small computation, and the same kind of thing that happens in machine learning. Okay, so when you're using GPU, the overall calculation capacity of your system increase manifold, because how many processors you have on your computer. Okay, in the processor there are some cores, right? There's one processor, and on processor you have generally maybe quad core, octa core. So you generally have four processors, four cores, 8 cores, right? But what exactly happens in GPU, the individual core is not that much powerful, but you generally have like 100 cores, 1000 cores, 4000 cores. So the number of cores are multiplied by many, I will say 10 times, 20 times, or maybe 100 times. And because of that, what is happening, that the calculation that you can do parallelly, that grow manifold, right? And because of that, people say that when you are going for machine learning, you generally prefer a GPU laptop. Okay, so that is the thing that I'm saying right in the front. Okay, so because of that, I will suggest that GPU, for the GPU, and you probably have GPU on your system or not, so you can use Google Colab for free, and that is a great way to go, and especially to start with. Okay, so I think you understand that much, and I can move forward with this. Okay, so let me start with this one. Okay, so For starting with the basic concept of, I will say image processing that we have to do with, I will, say that we need to load an image. Okay. And we want to reflect that here. Okay. We want to load an image and we want to do some operations on that. So what exactly is an image and how do we load it? So image, just think of the image like what? Like this 3D box. Okay. An image is like a 3D box where we have what? We have this, this, and this. We are saying that we have some rows, we have some columns, and we have some depth. Okay. And what is row, what is column, and what is depth in the case of an image? Just think of this. What is row, what is column, and what is depth in the case of an image? So you generally see on the screen, everything is a pixel. This is a pixel, this is a pixel, this is a pixel. You're seeing the whole screen as a pixelated thing, and every pixel have the value like R, G, and B. Everybody is comfortable with this concept. RGB values. R is for red, G is for green, and B is for blue. So whole image is more like this only. And if we want to load an image here, like we have this what is your favorite Avenger? Let me just consider right now that is this Thor. So if I say that you have the image of Thor, okay, and let us suppose we have this image. This is a good image to have. We save it, desktop D2 and MLWS, and let us say we name it Thor JPEG. Cool. So if we come and refresh it here, we have this Thor.jpg here, and we have this pre-installed library. Import image from PIL. Sorry. Oh, actually, it generally happens when you use a lot of programming languages at the same time. I was mixing the concept of JavaScript in Python. Okay, and image dot open, and we say that we want to open Thor.jpg and we save it in img. Cool. If we say that we want to showcase this image here, as simple as that, boom, we just loaded this image and we just reflected this image on our console here. Okay, just think of this, if you are not using Python and you are using some random language, how difficult that can be. Okay, it will not be as simple as this thing. We can be very sure about that. This will not be as simple as this thing if we are using any other language, right? So we simply loaded the library, we loaded the image, and we can reflect that. But at this moment it is not in the way that we want to use it, because we want to use it in numpy fashion, in the array fashion. Okay, and right now it is not in the array fashion. We have to convert it into a array, and for that we also have a library named numpy. So import numpy as np. And what is numpy? Numpy is simply a library where in the Python you are having a native array kind of thing. Because what generally you understand that in case of Python there is no array, and if there is no array, there is not a contiguous memory allocation, there is no random access. Because if you think of the list of Python and you think of random memory allocation, and visiting a random location at the constant amount of time, that is not happening. Because in case of Python, a random location take nearly constant time, not exactly the constant amount of time. And because of that, a lot of troubles that can happen in reshaping and doing a lot of different kind of operation that pops up. Okay, so when we are talking about numpy, what exactly it is doing, that behind the scene it is using the native C and C++ array, it is, what more specifically I should say, that it is using the native array, but you don't have to directly get interacted with that. You simply have to take care of your Python side array, and inside it is doing its thing. Okay, so if you are able to understand this much, what I can simply say is that np dot array, and in this array I'm passing my image, and I can say that it is arr. And if I ask for the shape of this arr, it is simply telling us, sorry, not arr. Okay, it is that you have 439 rows, you have 780 columns, and you have depth of 3. Okay, obviously if I showcase you this thing, so it is like, it is the first pixel, it is the second pixel, it's the third pixel, and this is the way we are, showcasing the thing. Whole of this image is just individual pixels, and if we are simply collecting them and reflecting them, we are getting this image. And it is as simple as that. You are just showcasing this image with the help of pixels only. You're getting this much, guys? Okay, so if you are comfortable with this thing, then what we can move forward with? Okay, so we have another library named matplotlib. So import matplotlib dot pyplot as plt. Cool. And with the help of this plt, we can image show our array. Okay, so just think of this, that initially you had a way to reflect this image with the help of this pillow library, but now you have converted into an array, and you still have the same capability. You have the same capability with the help of this plt. Okay, now you are reflecting the array of matplotlib type with the help of this plt. Okay, cool. So now we have this image in the fashion where we can do the operations on this image. Okay, so for doing these kind of operation, what we simply can do, we have OpenCV. Okay, and that is installed, so we can simply say that import cv2, and with the help of cv2, we have imported it now. We can do a lot of operations, like we want to convert this image into grayscale. We could simply say that cv2 dot convert color of this air image into what? cv2 dot color bgr, yeah, rgb to gray. As simple as that. And now we have the gray image with us. We want to reflect it. What we can simply do, plt.imshow and gray. As simple as that. Okay, so you will say that this is not grayscale. Why, how exactly this thing is happening? Why it is not gray? Because it is using a separate CMap. It is using a separate color map. But we can say that we want to use a specific gray color map. Sorry, we have to provide it as string, and it is a gray colored schema now. Okay, and same way we can resize the image, we can crop the image. All the kind of image processing operations you can use from here. Okay, all the image processing operations you can have from here, and that is good, that is great. And the most awesome thing that we want to do at this point is that we want to detect where the human face is in this image, and we want to put a rectangle over it. Won't it be great? We simply want to find the faces in this image. Okay, and for that, what we can simply do, we need a classification algorithm. And for that, the specific one that we will be using, just one second, I got a package from Amazon. I will have to download it. Yeah, I'm back. So yeah, so we'll be using har cascade. Okay, so har cascade frontal face, we will be using this XML, and we'll be using this XML to classify our faces. And what exactly Har cascade? In Har cascade is an algorithm which is saying that we have features and we are cascading those features correspondingly to find something. Okay, and when we are saying that you want to find a particular face, where exactly is the human face, you can use this algorithm for the same thing. And what you can simply see is that it is just the chunks of numbers, which exactly is specifying what kind of feature is where. Okay, and we are simply getting the raw file corresponding to this, and we are saving it. We are opening the raw file, and just 1 second. Yep, here's the raw file, and we saved it into D2. Cool. As simple as that. Refreshed, and we have our Har cascade frontal file here. We can say that we want a classifier is equal to cv2 dot cascade classifier, and we want to provide the path to this image. We do not want the whole path because it is relatively in the same folder, so we can do this. Okay, cool. We can still move this. This classifier is gone. We can say simply classifier dot detect multi-scale, and we can pass our maybe grayscale image or the complete image. And now we have this. What is this? We have X, Y, width and height of our face. Bam, that's nice. We are saying that we are getting a face from nearly 350, from nearly 350 and 67, that is 67 from the top, and we are getting a face of 78 by 78 pixels. So we are getting this face. And what if we want to crop this face? What if we want to crop this face to get only the face of this person, or maybe we want to put up a rectangle over it? So how do we do that? Let me just showcase that we have this whole image here, and we are saying that we have this face here, and for which we have this X, we have this Y, we have this width, and we have this height. X, Y, width, and height. We have these 4 values here. Okay, so what we can simply say, if we want to crop this by using normal Python slicing concept, the first thing that we have to do is that we have to get XY width height here, and we can simply say that from the values that we got here, we can say that these are the faces, and we have to get the 0th face, and we have to expand it here, and we have got X, Y, width and height. So if we have to do the slicing, we can simply say that from the image, this array that we have, we want to go from what? The rows that we have is from Y, that is the initial row, and the last row is Y plus H. So we have to do the slicing of Y to Y plus H, and in the case of columns, from X to X plus W, X to X plus W. Good. And we have this face here. And if we simply want to showcase this face with plt.imshow, we can do that. plt.imshow, we have got this face. Boom. Isn't it great? We have detected the face of Thor from this image, this complete image. So this is one way to go. But the second way is, if we want to simply put up the rectangle over the face, we could simply do that with the help of cv2. cv2 dot rectangle. Bam. Okay. What are the parameters that we have to pass? We have to pass the image, that is r. Then we have to put up the point one. Point one is this point. Okay. This is what? X comma y. X comma y. Then we have to provide the second point, that is the last point of the rectangle, that is x plus width and y plus height. Cool. X plus width and y plus height. Cool. Then we have to provide the color in the BGR fashion. So let us suppose we want to put up the blue, then 255, 0, okay. Then we have to provide the color. Sorry, color is done. The thickness, then let us suppose thickness is of 5 pixels, and we are not providing line type or anything. So it is providing a response. So let us suppose we have this result, and now simply what we want to showcase this result, plt.imshow, and we have this result here. Boom. Isn't it great? Right, guys? We are simply putting up this rectangle over the face of Thor. And we haven't decided, with the help of values, we have used the face detection algorithm with the help of this Har cascade frontal, Har cascade is the name of algorithm. And the frontal face is, like we are seeing the front of the face. Like there are a lot of different kind of, cascade values that we can use here. Like when you go for Har cascade, you have frontal face alternate, left eye, right eye, lower body, profile face, right eye. Okay, so you have a different kind of values that your OpenCV provide, and these are just the values that OpenCV is providing as the standard setup, but you can use even more. You can have much more values that you can use, and you can generate the data from that. Okay, so you are simply, this is the thing that I am doing correspondingly to this system, this very simple specific system, where things are much more easier for you. Okay, but what if I want to use this simple similar kind of code with the help of PyCharm? Okay, because the problem with the Jupyter notebook is that it generally do not support the video streaming system from I will say that your native camera. So if I simply do this, I create a new project in my PyCharm, and I use my normal Python 3 installation. Let's see, not this bootcamp. I want to use the D2, and we were using this folder here. I create a new folder for charm, create, open, and create. Cool. So we'll be doing the same thing, similar kind of thing that we were doing earlier, but now we will be using our webcam. Okay, and that will be much more interesting, right? So what we are simply doing here is that we are saying that create a file for us, and let's say it's a welcome file. And just to check the thing that we are using, we have all the setups installed in that. Import CV2, right click and run. Okay, we will need to change the interpreter. This kind of problem is happening because we have a lot of interpreters. So I need to change that, but generally this kind of problem do not happens when you are simply starting with the things. Control environment and charm, not this one. I want board, open, existing environment, Anuj. Just 1 second. You guys don't have to worry about these, because generally you don't have to do these kind of operations, because these kind of things are generally, pre-set up for you. You simply have to install some basic libraries. I am doing this because I have a lot of different kind of Python setup in my system, and I have to generally change them corresponding to the requirement. Okay, so it is just doing that stuff for me, and now we can move forward. And after this process part is done, we can simply check that this CV2 is there, and we can use that. Okay, this updating the skeleton and the things are about to be done, and now we can check that. Okay, so the thing that we will have to do after this part is done is simply that we have to stream from our camera. Okay, and we can use that. So for that, we simply have to first check if the run path is working properly or not. Yes, it is. We are not having any error. Okay, so what we can say that now we want to use our webcam. Okay, and for that we have to set up a capture stream. Okay, so from CV2 we have to create a video capture 0. Okay, 0 is for webcam, but because we also have a lot of other cameras on our system, so because of that there can be a smaller problem with that. So we will need to check if our default camera will work at 0, 1 and 2, and at what value, because we have a lot of virtual camera in my system. But in your setup it will work at 0. Okay, and when you have a capture, you can put up an infinite loop, and in this loop you simply have to keep on checking what you have with cap.read, and this read provide two values. Okay, if it is returning something or not, and what is the image it is returning. Okay, as simple as that. If it is returning something or not, and what is the value it is returning, it is providing you these two values corresponding to this operation. And if it is returning something, if it is returning the image, then only in that case you are liable to showcase the image, and that is this image. Okay, but at the same time you also have to provide the window name, and that is my camera. Okay, as simple as that. Boom, you have this image and you have showcased it. But now what you have to do is, because the frames are changing, you have to provide this wait key, cv2 dot wait key, and wait key will have a delay of maybe 1, and corresponding to that it will return a key. Okay, and you have to check which key is this to really get the out of this infinite loop. If you can say that this key is equal to old value, that is unicode value of your queue. You're saying that if I press q then quit from this application, you can simply do this break, and after you get out of this loop, what you simply have to do, cv2 dot destroy all windows. Boom, right click and run. Okay, so the first one was pointing toward IREM, and because of that, we are having this IREM virtual webcam system. But we don't want to do that. We don't want to go for IREM. We want to use a different camera. Okay, now we have our own camera. Boom. This is the thing we wanted, right? We are using our camera and we are seeing our face, from that. And we have already used the concept where we can detect the face and we can put a rectangle over it. So we will simply copy paste that code here. And after that, in this video stream, my face will be detected. And how cool is that? Isn't that cool? Right, guys? So we will do that now. We will simply close this one and we will copy paste the code, what we have already done. And that's it. So we'll be using this file in this folder, right? And we'll be using some code, and that code is, just one second. We'll be needing this classifier, and we will be needing the faces, Just 1 second. Let me, or what we can do is that let me not copy paste it so that you guys can understand how exactly things are happening. We will simply do that. Okay, so we have loaded this XML. That is fine. And the second thing is to get the faces. That is simply like this. You know, or I should not do this here. Only if we got some value we can have some faces, right? So we will do that here. We will not use gray, we will use image. Okay, and now we might have some faces, we might not have some faces. Okay, so if length of faces is greater than 0, okay, at least we have one face. Only in that case what we will do, we want to put rectangle over all the faces. Okay, so if length of faces is greater than 0, for face in faces, and all the face we have to expand. Okay, so what we can simply say is that for all the faces we want to get x, y, width and height. And now what we have to simply do is that we have to say that we want to put a rectangle over it. After the detection is done, we have to put up this rectangle. Okay, so result is equal to, we don't have this R, we have image, and we are putting up the rectangle. Let's have the thickness of 2, and we are replacing the image, and that's it. Right click, run. Just 1 second. Oh, sorry. We are doing the I am show before this, not after this. Because of that, there's this problem. So, you want to showcase the image after you have drawn the rectangle, not before that, right? So if you show before, sorry, screen sharing is paused and resume share. So that's it, run. Boom. Isn't that great? Right? So we haven't done something very big. We have done only the very simplistic code, very small code. But you have realized what exactly it can create. What is the power of the system? Okay, and how exactly you can write very small and simplistic code, but just keep on arranging the logics, and because of that, you can create something very awesome, something very useful. Okay, so that is my point today. That with the help of these kind of small things, you can really create something meaningful and something big. Okay, so just do that. And if you want to learn something awesome about machine learning, we have a very awesome resource for you as well. And let me just check if the link that I remember is right or not. Yeah, it is working fine, perfectly fine. So this is the link. Let me just write it down in the this section for you. This is the link. We have this platform called for cause. Probably some of you have heard about it. And we have this awesome machine learning playlist on the YouTube, where you can find us and you can the things that I have shown you guys today, you will find many fold of these things there. Okay, this is the playlist link I'm providing you guys. So if you open it there, you will have all these things: introduction to machine learning, image processing, invisibility clock. Like if there is a green cloth, you can wrap it around you and you will be invisible, like Harry Potter movie. Okay, like TensorFlow and all these kind of awesome things are there. Okay, this playlist is there. You can go there. You can simply watch it for free. You can understand things, or also with all the videos, you will see that there is a Discord channel link. Okay, if you get stuck, you can ask the doubts there. Okay, This is a very awesome and free resource. Go through that. You will learn a lot. You will find a lot of awesome things. You can share it with your friends, and that is, rest is up to you. Whatever you can grab, you can grab, and that is totally free from our side. Isn't it great? Isn't it awesome? Okay, so let's code for cause, and that is all from my side today. And see you guys soon. So, team, you can take over. Hello. Okay, I think these guys are not here yet, so don't worry about it. We can keep on having our discussion. So if you guys have any questions, you can put that up and we can discuss over them. You have any questions about code for cause, you can have any question about machine learning, you can have any question about anything, you can put up the question and we will respond to that. Don't worry about it. Just put it in the chat and throw it away. And you can also tell us, if you like the thing that we did today or not. You can revisit this video and go through things. If I think there was one guy who got stuck with some work, some errors. You can also put that thing again. Okay. Karthik is saying that there was an error in CV2 installation. Okay. You can put up the error, and corresponding to that, we can check, because there can be a lot of errors when you're installing CV2. And generally, the right way to install is to use OpenCV Python. Let me just share my screen again. PyPy, OpenCV Python. Okay, so this is the module that I will suggest you guys to install, right? Okay, there's this question: is computer vision part of ML? So computer vision in itself is not part of ML, but there is this intersecting structure for that. And why is that? Because just think of what exactly machine learning is. Machine learning is when you're learning from the data. Computer vision can be considered in separate dimension. Computer vision is simply saying that you are utilizing what computer can see. Like, you are utilizing the images and you are utilizing the video. Okay, and that's it. You're utilizing these things and that's it. You're not saying that what exactly it is for, what exactly it is giving. You're not putting anything on that. You're simply saying that you are utilizing what computer can see, and you can use it for any case. You can use it for reinforcement learning. In that case, it is not machine learning. You can use it as a I will say the normal feedback loop of x and y's. Corresponding to that, that will be machine learning. So what I will say, that in completeness it is AI, but you know it is completely in the domain of AI. The computer vision is AI, but in which subsection you are using the computer vision, that is totally up to you. Because computer vision by default is simply saying that you are just processing the thing that computer can see, that is images and videos, and that's it. That is it. Okay, cool. So any other question?
Hello, sir. This is Samir. I think Dhaval's having some internet issues. So if there's nothing else, then we can wind up now. Hello, sir. Can you hear me?
Yeah, I can hear you. So I think there is nothing else. We can wind up now.
Yeah, sir. So I would like to thank you for
Yeah.
joining us today and giving such a beautiful webinar. And then we can
Thanks.
wind up. Thank you, sir.
Yeah, sure. Thank you. See you
Yeah.
guys. Bye.
Bye. Thank you.